Alright, so this video will be discussing October, November 2023, okay, for stats 1, which is paper 5 lah. And then we are discussing about paper 5 too. Alright, so let's discuss question number 1. Alright, so if you read the question, there's a competitor, right, in a throwing event has 3 attempts. Then the random variable x means the number of throws to exceed 30 meters, that exceed 30 meters. The probability distribution table for x is shown below. So this is what we have here. Okay, then they are telling us that expected value of x, which is the mean, equals to 1.1. They want us to find the value of p and also the value of r. Okay, so to answer this question, because you can see that there are two unknown here, right? So p and r are two unknown. So to find out the value for these two unknown, I need to form two equations to solve them simultaneously. Alright, so for the first information that I'm going to use is, we need to know when we are having a probability distribution, the summation of all the probability should be equals to 1. Okay, so this is the first information I'm going to use. So, which means that I'm going to take all the probability here, okay, at the second row, I add them together and let it equals to 1. So 0.4 plus P plus R plus 0.15 equals to 1.1. Okay, so by moving the other thing over to the other side, so I should have P equals to 0.45 minus R. And I will make this as first equation. Right? Then after that, the second information is they are giving us the value of, expected, the mean equals to 1.1. So to get the mean, what's the general formula for the mean? Expected value of x, the general formula is you have to multiply x with the p, with the probability, and then you add them together. So this is what I'm going to do here. Right, so we are given, okay, so ex equals to 1.1. So to write out the formula for expected value of x, you take x multiply with probability. So 0 multiply with 0.4, you get 0. So I didn't write it out. So the next value will be 1. X equals to 1 multiply with p. So I'm having p. Then plus x equals to 2, have to multiply with r. So 2r. And the next one will be 3. X equals to 3 multiply with 0.15. And this is the mean. It is equals to 1.1. Right? Then again, I will rephrase everything. Move everything to one side. I keep only p on the left. So if you didn't do any careless mistake, by right, you should have this value. Right? Then of course, to get the value for p and also the r, you have to solve them simultaneously. So you let 1 equals to 2, and then you try to solve them. Okay, then when you try to simplify it, you'll get the value of r, which is 0.2. And of course, if you substitute r back into either equation number 1 or equation number 2, then you'll get the value of p, which is equals to 0.25. Okay, so this is what we have for part number A. Then let's proceed to part number B. For part B, they want us to find the numerical value of variance x. Alright, so just to recall back, how to find the variance x, yeah? So variance x, basically the formula is mean the expected value of x squared minus the mean square. Okay, so you already have the mean basically, right? So our mean is actually given here 1.1. So before I can find the variance, I need to find out the value for expected value of x squared first. So what's the general formula for expected value of x squared? It is actually the summation of x squared multiplied with the probability. That means you have to square the value of x, multiply with the p, the probability, and then you add all of them together. So we'll start from expected value of x squared first. Okay, so again, I go back to the table here. So 0 square multiplied with anything still 0, right? So I didn't write it out. So 1 square multiplied with p, and now your p is 0.25. So if you write it out, it should be 1 square multiplied with 0.25. Then plus, the next value will be x equals to 2, so you are having 2 square. Then multiply with the probability, which is a r. The r is equals to 0.2. So x squared multiplied with 0.2. And after that, for the third value will be 3 squared multiplied with 0.14. Okay, then I should be having this value, which is 2.4. Then after that, only I will start the calculation for the variance. So to get the variance, basically what I have here is 2.4 minus the mean. Mean is 1.1, and then you square it, right? And if you didn't do any careless mistake, by the help of calculator, you should get 1.19 as your variance x. Okay, so this is how we solve question number 1. Okay, so for question number 2, we are having the fair 5-sided spinner. Then label 1, 2, 3, 4, 5. And then he spin the spinner and notes the number of the side where the spinner lands. Okay, so they want us to find the probability that it takes fewer than 7 spins for George to obtain a 5. Okay, so what is the distribution for this question? It looks like there's no keyword, right? But you try to understand the meaning of the question. They are interested in how many spin they need to throw, okay? How many spin they need to throw the spinner until they obtain a 5. Right, so fewer than 7 spins to obtain a 5. That means they need to repeat throwing the spinner until they get a 5. So you have this until get something or until obtain something. Basically, it belongs to geometric distribution. Okay, then x is the number of throw. Alright, so it is geometric distributed. And what is the p? So p is the probability of obtaining a 5 in a single throw. So basically, it is 1 over 5. Okay, then they are asking us to calculate the probability for x smaller than 7. To calculate the probability for x smaller than 7, if you want, you can apply a shortcut where there's a general formula in this. So it is actually equals to x smaller equals to r, that is equals to 1 minus q power r. You can use this if you want. This is a shortcut basically, but it is not provided in the formula booklet if I'm not mistaken. Okay, so you actually need to ensure that when you want to use this formula, right, you have to ensure that the symbol here, it should be x smaller equals to, must have the sign equals to. Then only you can apply this formula. Okay, then if you go back to our question here, they're asking for x fewer than 7. X fewer than 7 means what? It has the same meaning as x smaller equals to 6. So I have to change it, become this pattern. Then only I can continue to use the formula that I shown just now, this one. So it will be 1 minus q power r. So it will be 4 over 5 power 6. Okay, then by just using calculator to help you, you should be able to get 0.738 as your final answer, correct to 3 significant figure. Okay, so this is how we get the part A answer. So maybe some of you not able to remember the formula here, right? Then you can have another option of the step where it will be much more longer. Okay, so if let's say they are asking for x smaller than 7, that means you need to include, okay, all the cases for x smaller than 7, where you might have one throw already get a spinner with a 5. Or you might have need to throw 2 times, okay, to get a 5 when you throw the spinner. Okay, then also you might need to throw it 3 times to get a 5, 4 times to get a 5, 5 times to get a 5, and also 6 times to get a 5. So you can see that the step become much more longer if let's say you are not able to remember the formula here. Okay, then what is the probability for x equals to 1? That means when you throw for the first time, you already get the probability, the 5, sorry. So it should be 1 over 5. So first throw already get the 5, so it should be the probability of 5 here. When x equals to 2, that means first throw, you don't get the 5. So it should be 4 over 5. You get some other value. Then after that, for the second throw, you get 1 over 5. Okay. Then for the third throw, 3 throw also the same. That means the third throw only you get a 5, right? which means that the first two throw you didn't get a 5, so it will be 4 over 5 square. Then the third throw you get a 5, which is 1 over 5. So the same thing applies for the remaining throws. So x equals to 4 means first 3 throws I didn't get 5, last throw I get a 5, and so on. Okay, then this is basically we are trying to apply the very basic formula for the geometric distribution. Okay, so to calculate the probability for geometric distribution, this is a basic formula. Q power r minus 1 times p. Yeah, so by spending a little bit more of time, if you try to press the calculator, you should be getting the same answer, which is 0.7. So this is optional. So some students, they're able to remember the formula, then of course, it will become much more easier. You can directly apply it and get the answer. Okay, then let's proceed to part number B. Okay, so for part number B now, there has a limit of throwing the spinner, which is 10 times. So when you have a certain limit of doing some experiment or throwing something, okay, and after that they are saying that obtain the 5 more than 4 times but fewer than 8 times. So out of the 10 spins, right, more than 4, fewer than 8, something happened. So for this kind of structure of the question, it belongs to binomial. Especially when you have a certain limit, the total number of trial is fixed, then you should expect that it should be a binomial distribution. So my n is a 10. P here is the probability of obtaining a 5 for one throw, so it should be 1 over 5. According to the question, they are asking for number of throw more than 4 times, fewer than 8. So if you try to write it out, it should be something like this. No equal sign for both value here. Okay, then after that, this is a binomial distribution. So x must be a whole number, right? So what's a whole number? Greater than 4 but smaller than 8. So if you try to list them out, it should be x equals to 5, x equals to 6, and also x equals to 7. Okay, then we try to put in the formula for binomial distribution to get the probability. So x equals to 5 means 10c5, p power 5, q power 5 also. Okay, then 10c6, 1 over 5 power 6, and then 4 over 5 power 4. And for the last one is 10c7, then p power 7, q power 10 minus 7, so which is a true. Okay, then just make sure that you press calculator very carefully to make sure that you don't do any careless mistake. If you didn't do any careless mistake, then this one should be your answer, which is 0.0327. So this is how we solve question number 2. Okay, so we are at question number 3. There's a factory produce a certain type of electrical component, and then we know that 15% of the component produced are 40. So this is a P, right? 15%. Then we are having 200 component is chosen. More than 40 of these components, something happened. Something happened here is the 40 lah. Okay, so you have a certain fixed value of component. Then more than 40 of these components, something happened. So according to the question just now, right, in question number 2, you can see the structure very similar, right? Actually, this one belongs to what? It belongs to binomial distribution. But now our n is a bigger number, which is 200. And then what is the p? P is 0.15, which is 15%. Okay, when we are having a large value of n and also a small value of, large value of n, you can actually double check and see whether it fulfilled the condition to change become normal distribution or not. But actually for this question, right, they already give us a very obvious hint. So you can see the keyword approximation. So approximation in AS, basically we are having only one type of approximation where it is binomial to normal. Okay, so I can directly change it become normal. But for those who are interested, if you are interested to check the condition, right? So basically this is a condition. You have to check whether your n is greater equals to 30 or not. That's the first one. You have to check whether n times p, n times p, is it greater than 5? And also n times q, is it greater than 5? So if let's say it fulfills these three conditions, right, basically you can change binomial and become normal. So for our case, because they already give us a very obvious keyword of approximation, so you can directly change it. How to get the normal? The parameter in the normal distribution. The first value here should be mean. So how to get the mean? So you should take 200, multiply with 0.15, and you get 30. Okay, so maybe for this part, I just try to write it out. You are using n times p, which is equals to 200, multiply with 0.15. Then how about the variance? So variance should be np cubed. So you take 30, multiply with 0.85. Then by right, you should have 25.5. Okay, so again, for details or understanding purpose, this one is actually npq, which is equals to 200 times 0.15, then times 0.85. Okay, all right. Then after you get the mean and also the variance, of course, you can continue to do the calculation for probability. So they're asking for more than 40 of the component are faulty. So the number of component faulty is more than 40, more than, so no equal sign, okay? Then since we are changing binomial, become normal distribution, right? Binomial belongs to discrete random variable, and the normal belongs to continuous random variable. So which means that the value of x for binomial, right, they are having a gap. They only take usually the whole number. But for continuous random variable, they always take range. So to adjust them from discrete and continuous, right, to adjust the space between them, we have to do continuity correction. So the continuity correction for this question should be x more than 40.5. So again, for those who want to know the detail, like how to do a continuity correction, you can refer to the lecture video, okay, that's available in the playlist. All right, so it belongs to paper 5, chapter 5. Okay, then after that, after you apply the continuity correction, because x now become normal distribution, so to calculate the probability, I have to change it become z. How to change it become z? You take the value of x that you have, minus the mean, which is minus 30, then divided by standard deviation, so square root 25.5. Okay, so please ensure that you show the step for standardization, and you will get z greater than 2.075. 2.079. Okay, so for this value, a small reminder here, the value of z, we need to find it up to 3 decimal places. Okay, because for our normal distribution table, right, the value of z that we're able to find is up to 3 decimal places. So you have to find out up to 3 decimal places so that you can get the most accurate answer. Okay, then let us continue further. To get z greater than 2.079, it is actually equals to 1 minus z smaller than 2.079. Why I need to change it become 1 minus z smaller than this value? Because for our normal table, they provide the value z smaller than something. So I have to change become z smaller than something. Only I can find out the value from the table. So let's proceed to the table here. We are looking for 2.079. Yeah? Okay, so this is z, right? So you have to look for the value of z from here. What is the value? 2.079. You go for 2.0, then 7 is this one. So if you read the value here, it should be 9808. So 2.07, and I need a 9. So the 9 is here actually. Okay, so what's the meaning for the 4 here? So basically it means that you have to add the 4 to the last digit, okay, in your table, in your probability. So 9808 plus 4, you get 9812. That means the probability of Z smaller than 2.079 is actually 0.9812. Okay, so simplify the answer, and by right you should get this, which is 0.0188. Okay, yeah, so this is how we solve this question number 3. Okay, so now we are at question number 4. We are given the heights lah, okay, in cm of the 11 players in aces and also jets are shown in the following table. So these are all the heights for the players. Okay, so they want us to draw a back-to-back stem plot, back-to-back stem and leaf diagram to represent the information with the ace and also left hand side, with the ace on the left hand side of the diagram. So they already mentioned clearly that ace team must be on the left. Okay, so to draw a back-to-back stem plot, we have to of course arrange the data, right, from lowest to the highest one. So first of all, please have a look what is the stem that we need to set or we need to form. So this is the stem. Stem will be in the center because we want to display the data of the two set of value, right, of two teams. So our stem will be in the center. They already set out clearly that ace must be on the left and also jets will be on the right. Okay, so first of all, let's decide the smallest value. So for the smallest value here, I think it should be something like 164. Then if you're looking for the highest value, I think it's this one, 190. So the smallest value is 164, the highest value is 190. Therefore, your stem can start from 16. Okay, and all my leaf here will be a single digit. Right, so 16, then I'm having 17, 18, and also 19. Then you try to put in the value one by one according to the step. So if let's say I look at the first height of the player, okay, in the ace team, so 180, therefore you have to put a 0 here, that means 180. 174, so you're having 4 here, which means that 170, 17, 4, 174, okay? Then 169, so you need to put a 9 here. So slowly you plug in every single value, okay, according to the stem that is related to the value. And after that, please arrange the value smallest to largest. So this is small and this is large. Okay, so if you try to arrange your value, okay, from small to large, right, finally your back-to-back stem plot will look something like this. So you're having 4, then 6, 8, and 9. Then for the second one will be 1, 3, 4, then 0, 1, 2, 2. Okay, all right, then how about for the right hand side? So right hand side will be, you have to apply the same step that I've shown you just now. Okay, but for right hand side, the smallest value should be here, and then going to be the largest value on the right lah. Okay, so if you didn't do any careless mistake, right? So your stem and leaf for jets will be 166 and 8 for the first row, then 0, 4, 4, 5 for the second row, 188 for the third one, and also 190 for the last one. Okay, so this is how a stem and leaf diagram looks like, alright, and it is back to back because you have to show or you have to display two set of data. Then before that, okay, before we end this question, we need to actually show them, okay, how to read the plot. Okay, so you have to show it with a key, show us with a key. So you can use any value that you like. Okay, so you have to just simply maybe use any number, any numbers can. So let's say I'm putting it something like this. All right, then of course these two numbers must be different. The ace team and also the jet team one try to be different so they can show clearly. So when you're having this one, you have to tell them that, oh, when you are reading the value like this, right? So it means that you are having a height for 182 cm for the ace player. So when someone who read the back-to-back stem plot, at least they know that, oh, okay, this is how we read the question, how we read the stem plot, and what's the meaning for the stem plot. Then for 181, you'll be 181 cm for jets player. Okay, so by right, your complete back-to-back stem plot should look something like this. Okay, so you should have the back-to-back stem plot itself and also the key. And for the key, please write out the sentence or the statement clearly, especially with the unit. Right? So this is how we solve part number A. Okay, so let's have a look for part number B. For part number B, they want us to find the median and also the interquartile range, okay, of the heights of the player in Ace. Alright, so if you want, you can try to build the value from the back-to-back stem plot, okay? But for me, maybe I lazy to scroll up and down. What I do is like I try to list up all the value here so that you can see more clearly. So I'm having lowest value 164, 166, 168, then 169. So 171, 173, 174. Okay, then 180, 181, 182, 182, then this is the last number already. Okay, actually by to find out the median, also the interquartile range, right? You just need to use common sense to find it out. So median means at the center location of the whole set of data. So where's the data which is in the center of the whole set of data? So you're having 11 numbers in total, right? Okay, so you have 11 numbers in total. Therefore, the center value should be the, which one? 11. So that means it should be the 6. Okay, so this will be the center of the set of data because in front got 5 values. You can see that in front got 5 values. After this one, also got 5 values. 1, 2, 3, 4, 5. So that means this is actually the center of the whole set of the data, which is the median. Right, so from here, you know that median is equals to 173. So please don't forget about the unit. Alright. Okay, then continue with interquartile range. So interquartile range means Q3 minus Q1. So I need to find out Q3 and Q1 first. So how to find out the Q1? Okay, so to find the Q1, ignore the median because your median is a whole number here in the center, right? So please ignore the median. We only focus on the first 5 number in the first part. So in the first part, the first half of the data, right, we are having 5 data here. So Q1 means the median of the first half. So the median of these 5 numbers. So where's the median for these 5 numbers? Again, if you have a look, it is very easy to decide that the median, okay, which is the center location of the first half of the data is 168. So this one will be belongs to Q1. Okay, so same concept applies for Q3. So for Q3, it is actually the median for the second half of the data. So this is your second half of data. Where's the center location of your median, your data? It will be this one, right? 181. Therefore, this will be Q3. Okay, so from here, you can continue to calculate the interquartile range, which is Q3 minus Q1. And from here, you'll get 13. So don't forget about unit, right? So you're having 13 cm for interquartile range, and also median is 173 cm. Okay, so of course, you can read all this value from the back-to-back stem plots, and just make sure that you read it carefully, okay, and you count carefully by using back-to-back stem plots. All right, then let's have a look for part number C. For part C, they want us to give one comment comparing the spread of the heights. So they're talking about the spreadness of the height. Okay, so let's have a look for this one. So to get the spreadness, right, basically we will see how many data, how widely the data are spread off. So for this one, you can see that for just the data are spreading from 160 over to 190 over. But for Ace one, you can see that they are more focused from 160 to 180 something. There's no 190 over. Okay, so from here you can see that the data from Jets are spread more widely compared with Ace. So this is a condition, this is a conclusion that you can make. Okay, so usually how I write it out is I just try to use a very simple word or simple statement. So yeah, I'm saying that Jets have or have a wider spread okay, in heights for the player, alright. Yeah, so try to make your simple your statement simple and easy to understand. Right? Okay, so this is basically how we solve question number. Okay, so question number 5 now. They are talking about the heights of the member of the club are normally distributed. So highlight the keyword normally distributed. They give you the mean and also the standard deviation. They want us to find the probability that a random chosen member of the club has height less than 170. Okay, so first of all, we know that height, we define x as height. right? It is normally distributed with the mean 166, standard deviation is 10. But for this one, I have to put variance, right? So I have to square it, right? Then they want us to calculate the probability of x smaller than 170. Okay, since we know that this is a normal distributed question, right? So, therefore, to find the probability if you change x become z. How to change x become z? So don't forget, you have to write out the step for standardization. So you have to minus the mean divided by standard deviation before you can calculate the probability or get the probability. Okay, so what's the value of z that you get? For this question, the value of z that you get is quite straightforward. It is 0.4. So we can directly find out the probability of z smaller than 0.4 from the normal distribution table. So 0.4, we are looking for value of z. And what's the value for 0.4 here? It is equals to 0.6554. Okay, then let's proceed back. So you're having 0.6554. Then of course, if you want it to be safe, you can cut it to 3 significant figure, which is 0.655. Okay, so this is how we solve part A, number 1. Then let's proceed to part A, number 2. Okay, now they give us that 40% of the members has the height greater than h. So when you want to write out this particular sentence into the symbol, right? How should you write it out? It should be the probability that the height is x greater than h means more than h is equals to 40%. So 40% means 0.40. Okay, and they want us to find the value of h correct to 2 decimal places. Alright, so for this, this is still talking about the height of the members, right? So basically, they are still having the same distribution where it is still normally distributed. Okay, we copy the mean and also the variance from the previous part. So you're having 166, then 10 squared, which is the variance. Alright, so again, x is still normally distributed. So I will change it become z by standardizing it. So I'm having h minus the mean divided by standard deviation. Okay, so equals to 0.40. If I try to draw a bell-shaped curve and shape the area that I want, right, for this particular equation, basically it will be something like this. Okay, so let's say this is a normal curve and the 0 is at the center. So when I'm having z greater than 1 value and it is equals to a small area, 0.4 means less than 0.5. So anything less than 0.5, I call it as small area. Anything more than 0.5, I call it as large area. So z greater than a number equals to 0.4 means that when you draw a line and you shade the area on the right hand side means greater. Okay, then the area is 0.40 means that it is a small area, the area which is less than half of the graph. So by right, your z should be somewhere here. Okay, so this is actually h minus 166 over 10. All right, and I don't know what's the value now, and I want to find it out. Okay, so this is actually 0.4. Okay, so the complement area for 0.4, this whole thing will be 0.6. Okay, so all of us know that when you want to find any value, okay, backward, that means from probability, you want to get the value of z. Basically, you need to make sure that you are having a large area. Large area means the value that is more than 0.5. Because if you have a look here, okay, all these are probability. And the probability that is shown in the table, right, everything is more than 0.5. Okay, so if you have a look for our question, we are having a smaller area, which is 0.4. So to find out the value of z, I need to use a complementary area, which is 0.6. Okay, so now to get the value of z, I will try to look for 0.6 and go out to get the z. So let's continue from here. I want to look for 0.6. So what is the 0.6? The value closest to 0.6 but lower than 0.6 is this one. So if you read out the value, so your Z value will be 0.25, but not enough yet, right? Because when you're having 5987, you need to add 13 to get 60. So you need to look for 13 at the back. So where's the 13 at the back? There's no 13. You have 12, you have 15. So usually we'll take the closest number. So I think 12 is the closest number already lah. Okay. Then you add one more decimal place at the value of Z, which is a 3. So if you continue to read the value, it will be 0.253. Okay. So my value of Z is equals to 0.253. If you look at this particular graph, right, you are aware that the value of Z will be on the positive side, which is greater than 0. Therefore, the 0.253 I will put it as positive. So it is equals to the value Z in our formula just now. Okay, then what you need to do is try to simplify everything slowly and get the value of H. So I think they did mention that your value of H should be in 2 decimal places, right? So by right, your H should be equals to 168.53. Okay, so this is how basically we solve the part A question. Then let's proceed to part B question. Okay, so now they are telling us that X is still normally distributed. Okay, but now I don't know the mean and standard deviation. But they give us the value that standard deviation equals to 2 over 3 mu lah. Then they want to find the probability that chosen value of X is positive. So chosen X is positive means that X greater than 0, positive, right? So you want to find the probability of X greater than 0. Again, this is a normal distribution question, right? You see the keyword normal, right? So you have to standardize it become Z. Again, what's the process of standardization? You have to take 0, then minus the mean. You don't know, you just put minus the mean, divided by standard deviation. Now you are given that standard deviation is 2 over 3 mu. So you have to put 2 over 3 mu here, which is the standard deviation. Okay, so before you continue further, right? So 0 minus mu, you get a mu. Mu and the mu, you can cancel off with each other. Alright, so if you simplify the remaining numbers in the, see that you should get 1.5 negative. Okay, then the area of Z greater than negative 1.5 means something like this. Okay, so this is negative 1.5. Greater than means on the right hand side of that particular number of the value Z. Okay, then again, I cannot find out the particular area because my value of Z is negative. All my normal distribution table, the value of Z are positive. Okay, so I need to think away and try to link for this area that I want to find, right? It is actually equals to what? It is actually equals to the area where you are having Z is positive 1.5 and this one. Okay, so you know that these two areas are basically the same. So I will write as Z smaller than 1.5. Okay, so when you're having Z smaller than a positive value, you can directly find out the probability from the normal distribution table. Go back to our table now. 1.5. So Z equals to 1.5. We are getting 0.9332. Okay, so apply the value here. You will have 0.933. Okay, so again, I will correct it to 3 significant figure and it will become 0.933. Okay, so this is how we solve question number 5. Okay, so question number 6. Freddy has 2 bags of marbles. Then we are having bag X and also Y. So bag X has 7 red marbles, 3 blue. Then for Y, we are having 4 red and also 1 blue. So Freddy choose one of the bags at random. So the very first step is he has to choose a bag first. Choose one of the bag at random. Okay, then a marble is removed at random from that bag and not replaced. So I think not replaced is also a very important keyword. A new red marble is now added in each bag. Then the second marble is then removed at random from the same bag that the first marble has been removed from. So this is generally the situation that we have for this question. So they want us to draw a tree diagram to represent the information showing the probability on each of the branches. Okay, so for this question, we are having X and Y. Okay, so we are having X, back X and also back Y. So for back X, I'm having 7 red and also 3 blue. For the Y, I'm having 4 red and also 1 blue. Okay, then let's draw a tree diagram first. Okay, so according to uh, the information provided just now, right? So you can see that our first step is we have to choose the bag randomly first. So to choose the bag randomly, basically we're having two outcomes, right? Either you got X and X or you got bag Y. So you choose the bag at random. So that means they're having equal chance to be selected. So it will be half and half. Okay, so when you already select the bag X, and now you are going to select one ball, okay, one marble. Is it one marble? Yeah, one marble from the X. So when you want to choose the first marble from the X, you can have either a red color marble or blue color marble. So the first marble that you choose, right? Okay, the probability will be looking at the original types of marble that we have. So we are having 7 red and also 3 blue. Total there are 10. So to get the red marble, it will be 7 over 10. And then to get the blue marble, you will be having 3 over 10. So after you take out the first marble, okay, you didn't replace it back. But one red color marble is added. Red marble is added into the same bag. And now we want to select the second marble from the same bag again. Therefore, if let's say you are having the bag X, right? After you select the first marble, you have the result of get the second marble. This is also the same thing. You are having the second result for the second marble. The result for the second marble. Okay, so let's have a look for the first possibility first. Okay, so we select the bag X. Let's say if the first marble that we select is red color. So that means now your red color become 6. Originally it is 7, right? So eventually it becomes, let me draw a bigger one. So now it becomes 6, 6 red. Because you take out one marble already, okay? But when you take out one marble just now, which is the red color, now you add one red marble into the same bag or into the each bag. So that means now you are having one more red marble added into the bag X. So now I still focus on bag X, yeah? Okay, then I want to look at the probability that if I want to select second marble, what is the probability that I get a red again? So now you see the total marbles in the box. It is still 10 marbles in total, right? Okay, and we are having 7 red color marble, right? So you are having 7 over 10. So to get the blue marble, so you have 3 blue, so it will be 3 over 10. So this is the first pair of branches that we have. Okay, then now we resume this back into the original one. Okay, then now how about if let's say I select the bag number X, and then the first marble that I choose is a blue color marble. So if you choose a blue color marble, okay, so sorry, I should write 7R and 3B. So if you select a blue color marble and you didn't replace it back, right? So your blue color marble will become 2. Okay, then after that, one red marble is added into the bag. 8 red marble and 2 blue marbles. So for the next marble that you are selected, right, you are going to select what is the probability to get a red marble? It will be 8 over 10 because 7 plus 1 is 8. Then the blue marble will be 2 over 10. Okay, so this is all the probability that we will have if you select the bag X and select the marble from the back X. Okay, then we go for the second possibility. If let's say you get the back Y, okay, then the first marble that you get might be red and blue, then the second marble that you get also might be red or blue. Okay, all right, then let's have a look and focus on the back Y. Okay, so for back Y, originally I'm having 4R, 4 red color and 1 B. 4 red and also 1 B. 1 blue only. Okay, all right. So now if let's say the first marble that I select from back Y is red color, so what's the probability here? So total there are 5 marbles in the back, so it will be 4 over 5. Okay, then if you selected one marble, one red marble from the Y, so you left only 3 red marble. Okay, after you select one marble already, they will add in one red color marble into the back, so you have one more extra red color marble here. Then now to select the second marble, what's the probability of getting a red color marble? So to get a red color marble again, total there are 5 marbles in total, and 4 of them are red color, so you're having 4 over 5. Then for the blue color one is complementary of R, so it should be 1 over 5. Alright, then if we go back to our original status for the back Y, I'm having 4 red and 1 blue. So what is the probability for me to select the first marble, which is blue color? It will be 1 over 5. Okay, and you can double check. These two probability total should be equals to 1. Correct or not? Okay, if you selected the blue color marble as the first marble, now you're having 0 blue marble. Okay, then before you get the second marble, they add in 1 red color marble into the back. And now you're having total 5 marbles, and all of them are red color. To get the second marble, which is a red color, the probability is 1. Then the probability of getting a blue color here will be a 0. Okay, so generally this is how we draw out the tree diagram. Okay, then you have to understand the condition or situation that they give you here. Okay, so let's have a look for next part. Okay, so for part number B, they want us to find the probability that both the marble removed from the back are the same color. Okay, so we are interested to find out the probability for both same color. Right, so you can actually use the tree diagram that you sketched just now, and we are only focusing on both same color one. So the first line that we are having is this one. Okay, so you can see that from back X, I select both R, 2 red color. Okay, that's the first one. Then the second one will be from the back X, I select both blue color. Okay, then what else do I have? Then the third case will be from the back Y, I select both red color. And also the next one will be from the back Y, I select both blue color. So there are 4 different outcomes here. Okay, so what you need to do is you multiply the probability along the pathway or along the route, and you add the answer for the 4 routes here. Alright, so as an example, the first route will be half multiply with 7 over 10, multiply with 7 over 10. Okay, so you can write half multiply with 7 over 10 and also 7 over 10. Then what is the second route? So to get the answer for the second route, you have to add them together with the first one. Okay, then to get the second route, you are looking at here, half multiply with 3 over 10, multiply with 2 over 10. Okay, so half 3 over 10, 2 over 10. Alright, so please do the same thing for the other route here and add all of them together. Okay, so the third one, half 4 over 5, 4 over 5. So half 4 over 5 and also 4 over 5. Then the last one will be what? The last one will be half and then 1 over 5 and 0. So if you want, you no need to write it out because anything multiplied with 0, it is always 0, right? Okay, so by using the help of calculator, try to simplify your answer. So if you didn't do any careless mistake, your answer should be something like this, 119 over 200. Or you can keep it into three significant figure, which is 0.595. Okay, yeah, so let us proceed to part C. So for part C, they're asking us now, find the probability that Y is chosen given that. So I will need you to highlight the word given that. This is basically a keyword telling us about conditional probability. Okay, so for conditional probability, when you want to write out the symbol, it should be something happen first. You have a slash here. Okay, so what's the something happen? Okay, so given that the marble removed are not both the same color. Okay, so that means you already know that the marble removed are not the same color. So it is happen first. So we write it here, not both same color. That means it will be one red, one blue, meaning, okay? Then after that, what's the probability that we are interested? They say Y is chosen. So you write the Y is chosen here. Okay, then for conditional probability, right, there's a general formula where if I take one example, if let's say I'm having A given that B, this one means A given that B, the general formula is A intersect with B, then divided by the probability of B. So we are going to apply the same thing here in the context of our question. If you try to write the formula, okay, according to what we have here, right? So you'll be having Y is chosen intersect with not both same color. Divided by the probability of B, which is not both same color. Okay, then next step is we are going to calculate or maybe try to get what is the probability for Y is chosen and also intersect with not both the same color. You can still use the tree diagram to help you. So I think for this question, right, the tree diagram basically is very important because it will actually affect all your result later. Okay, so now they said, I know Y is chosen, intersect with both not the same color. So that means they happen at the same time. So you are having Y, and then the marble that you choose not the same color. This will be your first route, the red color one or yellow color one. Then the second route will be you get the back Y, then you choose one blue and also one red. So these are the two possible outcomes that fulfill what we want here. Okay, Y intersect with both not same color. So this is the two route that we have lah. Okay, so again, to calculate the probability, you have to take half, multiply with 4 over 5, multiply with 1 over 5, then plus the second route, half, multiply with 1 over 5, multiply with 1. Okay, right, so let's us complete the step here. Okay, so the answer will be half. First route will be half, multiply with 4 over 5, multiply with 1 over 5. And the second route or second pathway will be half, multiply with 1 over 5, multiply with 1. And we divide it by 1 minus 0.595. So what is it? 1 minus 0.595. For not both the same color, right? It is actually the complement event of both same color. So since just now you already calculate the probability of both same color, which is 0.595, therefore, if I want to calculate not both the same color, it should take 1 minus 0.595. Okay, then if you try to simplify everything here by right, your answer should be 4 over 9. Okay, yeah, so this is how we solve this question number 6. Okay, so we are now at the last question here. Find the number of different arrangements. So highlight the keyword arrangement. This will give us a hint that our step later mainly is about NPR or maybe n factorial. Okay, then we are having 9 letters here. Then this is the word lah, Andromeda, I think. Okay, the number they want you to arrange it so that there's no consonant next to another consonant. So consonant means all the letter like D, M, N, R. Then all the vowel are A, E, O. Okay, so they said no consonant is next to another consonant, means that all the consonant must be separated. Correct or not? Right. When we want to arrange something that must be separated, the step is you arrange the remaining letter first, and last only you arrange those letters that need to be separated. Okay, so before we start, let's analyze how many letters do we have here. So basically we're having 2A, we're having 2D, and then we are having 1N, 1R, O, and then M and E. Okay, then if I want to separate them into consonant and vowel, so basically we are having 1, 2, 3, 4. So we are actually having 4 vowel. Okay, then 5 consonant. Okay, since the consonant must be separated, so we will arrange them lastly. Okay, now I try to focus on arranging these 4 letters first. A, O, E. Okay, so A, O, E. How are we going to arrange the 4 letters here? It will be actually 4 factorial. But because of the 2 A are identical, therefore you have to divide it by 2 factorial. Okay, so this is the number of arrangement for the 4 letters here. After that, we want to put in, okay, all the consonant. We are having 5 consonant here, and they have a restriction where the consonant cannot be next to each other. So that means if I want to slot in 5 consonant between the vowels, right, the only option is you need to slot them in the 5 spaces here where we draw the arrow. So you can see that you have 5 space to fit in 5 letters. Therefore, you can write it out as 5P5, or you can write it out as 5 factorial. So for your information, 5P5 and 5 factorial are having the same meaning and also the same answer. Okay, so you're arranging the 5 consonant here. So what are the 5 consonant here? You're having 2D, 1R, 1N, 1M. Okay, so you're arranging 5 factorial, and at the same time you have to divide it by 2 factorial. Why do I need to divide the 2 factorial again? Because from the consonant here you can see that you're having 2 identical D. Alright, okay, so try to multiply them together to complete the arrangement. Therefore, the answer that you get should be 720. So this is how we get the answer for part A. Alright, okay, then let's proceed further to part number B. Okay, so for part number B, now they give us some other restrictions here. Find the number of different arrangement of the 9 letter in the word of Andromeda, in which there's a A at each end and the E, the D's are not together. Okay, so for this arrangement, right, they have fixed the A with a certain position here, which is at the end, each end. So I have 1A in front, 1A at the last digit. Okay, then after that, I have 7 letters in between. So 1, 2, 3, 4, 5, 6, 7. So for these 7 letters, right, what kind of letters do I still have? I have 2D, then I still have N, R, O, M, E. Okay, then for this question, because they are telling us that the D are not together. Again, not together means must be separated. Therefore, we have to arrange them lastly, so that it is easier for us to slot in after we arrange some other people or some other letter. Okay, so let us start. Because A are fixed in front and at the in front and also at the back, so we are not going to consider any arrangement for the A. So we no need to arrange A at all. Alright. Okay. Then in the middle we need to arrange 7 letters, 2D, N, R, O, M, E. So like what I told you just now, 2D must be separated, therefore we arrange them at last. So what I do now is I try to arrange the 5 letter here first. Okay, so how am I going to arrange the 5 different letters here? So basically it should be 5 factorial. Do I need to divide anything factorial or not? No need, because all the 5 letters are different, all are distinct. They are all distinct. So generally you are having 5 factorial first. After you arrange this 5 letter, now you want to slot in the D between the 5 letters so that the 2D will be separated. So how many space available for you to slot in the 2D? So I draw arrow here. 1, 2, 3, 4, 5, 6. So you can see that there are 6 space available for 2D. So when you want to calculate the number arrangement, it should be 6P2, which means that 6 place available, you want to arrange 2D inside the 6 place, right? But these 2D are identical, therefore you have to divide it by 2 factorial. Okay, then after that, again, try to simplify your answer. By right, you should get 1800. Okay, alright. Then let's continue to part C. Alright, so for part C, again, now they're having 4 letters are selected at random from the 9 letters in this word. Okay, I want you to highlight the keyword selected. So when you see the word selected means that this is a combination question. So in your step, basically you're having NCR. There's no more n factorial lah, r factorial, all those things, but mainly they are about NCR or NC something lah. Okay, so you want to select 4 letters. Then find the probability that this selection contain at least 1D and exactly 1A. I want you to highlight the keyword probability. Okay, then when you want to select something, okay, when you calculate the number of combination, right, usually for all the identical letter, we are not going to consider the arrangement because they are identical, so usually we list out the case and then we calculate it without choosing the identical letter. But for probability of combination, you need to select the identical letter, okay, among the identical letter lah, because the identical letter actually means that you are having a higher chance to select them. So for probability, all the identical letter that is identical, right, you have to include that in the selection. Okay, so maybe to let you see the difference for this question, what I will do is like I will show you 2 set of answer where one part is to find out the probability and another part is to find out the number of combination only, so that you can see the difference between the number of combination and also the probability that involve combination. Okay, all right, so maybe first of all, let's have a look for the cases that we have lah. So they want you to have 4 letters, 1, 2, 3, 4. Then what is the restriction here? They are saying that you must have 1D and also at least 1D, sorry, at least 1D, then exactly 1A. If they want you to have at least 1D, means that you're having 1D here, 1A here. This is your first case. Or you might have 2D with 1A. So 2D with 1A. Okay, so the remaining space here, right? The remaining space that you can see here, basically you can fill in by using any other letter lah, except the D and A. Okay, right, so we're having 2 cases here. So the first case is 1D, 1A. The second case is 2D, 1A. Okay, all right. Then now, so this is case number 1 and this is case number 2. All right. Therefore, now I want to show you how are we going to do the calculation for this question. If the question is asking for number of combination, not the probability, yeah. So if they are asking for number of combination, so what we usually do is, for case number 1, we are not going to select the D because the D is fixed there. Although we are having 2D, we are not going to put it as 2C1. Okay, we are not going to put the D as 2C1, then A 2C1 because they are identical. So it is no point that you choose either one of them because they are the same and they will give you the same result. So for number of combination, what we do is we only focus on the two letters here. Okay, so these two letters, I'm going to select them from N, R, O, M, E, right? These five letters. So the number of combination for first case is 5C1. Alright, then after that, when you go for the second case, again, for the case of 2D and 1A, I'm not going to consider 2C2 for the D, 2C1 for the A, because they are identical letters, so I don't bother them. I only want to know how many results I have. Therefore, for the last number here, I only want to consider the possible result for the last number or last letter, which is N, R, O, M, E also. So from the, oh sorry, I think I make a careless mistake here. This one should be 5C1, right? Or 5C2, right? Because you're having two space. So from the 5 letter, you want to select 2. Then this one, you have 1 space, right? So to fill in the 1 space here, you are selecting them 1 letter from the 5 letter mentioned here above. Therefore, the number of combinations should be 5C1. Okay, then if they're asking for the number of combination, so you should take 5C2 then plus 5C1. So by right, you should have 15. If they're asking for number of combination. Okay, but for this question, they are not asking for number of combination, but they are asking for the probability of the combination. If they are asking for probability, then we need to consider all the identical letter. Now, because for all the identical letter, right, when you have more identical letter, like 2E or 2A, it actually means that you have the higher chance to get the letter D or to get the letter A. So to calculate the probability, we have to include the identical letter lah. You have to include them in the calculation. Alright, so now let's have a look. If let's say I want to have the probability, okay, for first case, I'm having 1D here. Because I have 2D right? So I need to consider from 2, I will have 2C1. 2D, I will choose one of them. Okay, because by right, D will have a higher chance to appear or to be selected for probability. Okay, then for the A also, I got 2A, so I have 2C1 also. Alright, that for the remaining 2 letters, I want to select them from the 5 letters here, so it should be 5C1. 5C2. So to calculate the probability, you have to divide your number of combination by, you have to divide the number of combination without restriction. So what's the number of combination without restriction? That means total you're having 9 letters and you want to select 4 of them. So it will be 9C4. So that's how we calculate the probability. And you try to observe, right? For number of combination, I only have 5C2. But for the probability calculation, I need to include, okay, the chances that D and A will appear, which is 2C1 and also 2C1. That means higher chance to be selected. Okay, therefore, this is how we calculate the probability. So if you compare, there's a small difference, right? Then after that, when we go for the second case, 2D, 1A, and one other letter. So 2D means I want to select 2C2, 2D, and I want to select 2 of them. And then for the A, I want to select only one of them, so 2C1. And for the remaining 5 letters, I want to select only one of them, so 5C1. Then divided by total combination without restriction, so it will be 9C4. Same thing happen here. If you try to use calculator to help you, this one will be 20 over 63. And the second case here will be 5 over 63. So to calculate the probability for these 2 cases, you have to actually total them up also. So the total probability should be equals to 20 over 63 plus 5 over 63. It should be 25 over 63. Okay, so the correct answer for this question should be 25 over 63. Alright, so by solving this question using showing 2 different results here, showing the number of combination and also the probability involved in combination, I hope that you can see the difference when we do the calculation here. Alright, okay, so this is the last question. Okay, so we'll end the video here. Thank you very much for watching the video.